Hello and welcome to this afternoon's webcast. My name is Evelyn and I am a principal consultant with Thorogood with 30 years experience of working in the analytics and business intelligence area. I'm joined today by my colleague Paul Taylor, also a principal consultant with many years experience working with multiple customers and technologies. Today we will be covering the following agenda. First, we'll give a very brief introduction to Thorogood. Then we'll get straight into talking about what an end goal looks like for customers investing in enterprise data platforms that can be used not just for reporting, but for advanced analytics that can truly help the business understand the drivers and influences in this fast-moving world. We will look at some of the key considerations for enterprises from a holistic point of view in terms of their current situation and also how to plan to deliver business value. Paul and I will then talk briefly about some customer examples, all starting from a different basis with different short-term needs, but all keeping in mind the end goal of providing an enterprise platform for analytics. And finally, we will summarise what we believe are the underlying principles that need to be adhered to in all scenarios in order to achieve success. For those of you who aren't familiar with Thorogood, we are an independent global professional services firm specialising in data engineering, data science and data visualization. Our multi-skilled teams understand the critical interplay between these three areas, and we help our customers leverage the latest technologies to make timely, data-driven business decisions. We create business-focused, end-to-end technology solutions robust enough to meet enterprise needs. Our services span strategy, implementation, user empowerment and support. We work with a number of blue chip customers, primarily from the consumer goods, pharma and life sciences, financial services and insurance sectors. As we're an independent company, we don't just work with one specific technology. We work closely with a wide range of the industry's best technology vendors, such as Microsoft, AWS and Databricks, to ensure we can provide our clients with business analytics solutions that best suit their business needs. So let's get on and discuss building an enterprise data warehouse with analytics in mind. Investing in an enterprise data platform that is analytics ready can drive huge benefits across the organisation. Such a platform can form the bedrock for solutions to meet local and global needs, leverage digital transformation to enable and automate efficient business processes, and provide insights to support data-driven decisions. But where do you start? For many organisations, the potential benefits of such a platform are huge and can increase data maturity to the point where data is a key competitive advantage. This is critically important in an ever-changing consumer and competitor landscape. But how do organisations prioritise and realise the business benefits and prevent the approach from becoming a pure IT initiative? Analytics is the end goal for all of our customers, particularly over the last year or so, where the need to react to what is happening in the market and what you think will happen is vital. This can lead to quick ad hoc approaches being taken, but ones that are not sustainable into the future. On the other hand, taking a vast amount of time out to invest in consolidating data into a single trusted source just isn't feasible. The big question is, how can you deliver continued value to your business while still driving towards this end goal? As I said, the long-term focus for most organisations is analytics or machine learning systems. But as this diagram shows, only a small fraction of real-world ML systems are composed of this ML code, as shown by the small black box in the middle. The required surrounding infrastructure is vast and complex and needs to be in place to fully realise all possible benefits. Looking at it from a different angle, it is also important to recognise that to establish a successful enterprise data platform for analytics, it is not just about the technology. The best approach a company can adopt needs to take account of where they are with regards to other aspects, such as data agility, the maturity with regards to analytics, the approach to take in terms of experimental versus operationalized analytics, and finally, the skills available to the organization. Any organization could be in different places on each of these spectrums, and understanding where you are can help guide the best approach to take. Knowing where you are, where you want to be, and how to get there is crucial. I'll look at each of these aspects briefly now, but if you'd like further information on any or all of these elements, please reach out to me or Paul, or look on our website on our perspectives page for other perspectives we have shared which go into each of these in more detail. This diagram is one we use to illustrate data agility and summarises different overall approaches to data management and governance. On the left, we have managed data warehouses, where the data quality is assured and there are robust processes employed to get data there. This is particularly important if you're operating in a regulatory environment. On the right is ad hoc data storage, or how a lot of people see data lakes. Data is there to be accessed and analysed, but does not come with the assuredness of a managed warehouse. And there is an agile approach in the middle, where some element of data certification has taken place, but there is still room for flexibility. If all of your organisation's data is held in a managed state, then this potentially removes the flexibility to react to market circumstances. Traditional business intelligence and reporting systems can continue to report in a standard way, but it does not necessarily allow for fast ad hoc analysis. We also have this concept of an analytics continuum, moving through different stages of analysis, from foundational aggregations and descriptive statistics through to analytical models and experimentation. The end goal is potentially always to the right of this spectrum, but it is important to recognise the readiness of your organisation to embrace this. If results are seen to be opaque and hard to interpret, are they less likely to be believed than the more traditional transparent analyses? In terms of organisational approach, how ready is your company to invest in ML Ops, that's machine learning and operations? To fully realise the benefits of enterprise-wide analytics, companies need to scale any experimentation into something that is enterprise-ready and robust enough to affect change. But there are fundamental differences between the needs for experimentation and operational ML solutions, as shown on this slide. Again, it's important to recognise where you are and where you want to be. And finally, it is worth understanding the skills that are needed in order to set up an enterprise data platform for analytics. These types of projects require a mix of skills and require collaboration across groups that were traditionally more siloed. One example being that an organisation could have data scientists experimenting in back rooms who then hand over their model to data engineers to be industrialised, all removed from the business stakeholders. The overlap between these roles is vital to ensure business value is delivered in the most efficient way. So with that, I'll hand over to Paul to talk about more of the detailed thinking required to deliver business value.
Thanks, Evelyn. When planning for an enterprise data platform with analytics in mind, there are three key objectives to consider when thinking of the evolution of that platform over time. The first is a focus on delivering value to the business. At all times, we need to keep user requirements and business value front of mind. This ensures we're not expending cost and energy on anything that does not add value at the right time. How we can get data and insights into the hands of the people that can make appropriate and timely decisions based on this information as quickly as possible. The second objective is delivering value at optimum speed. Very much linked to the first objective, how can the platform evolve such that it delivers key, possibly quick wins up front, whilst keeping in mind the subsequent requirements that need to be delivered? For example, delivering initial value at the fastest speed possible, but without considering the impact on delivering subsequent phases may result in the need to re-architect the platform and ultimately slower speed. The final objective is benefiting from synergies in requirements. Taking a top-down view of requirements from product to data can result in a fairly siloed approach to building your platform, but considering as much as possible up front the potential requirements across products will help identify where more than one product can leverage from a single platform to deliver early value and to avoid significant cost and time-consuming re-architecting of the platform. An approach to building an enterprise data platform with analytics in mind should ensure there is sufficient understanding of the ongoing requirements upfront to enable the prioritized implementation of subsequent use cases and progressively builds on and evolves the platform without the significant need for re-architecting along the way. When designing an enterprise data platform with analytics in mind, there are a number of key considerations that can have a significant impact on your objective of delivering business value. These largely fall into the categories of data, technical, and consumption considerations. First of all, let's consider data. The initial application deliverables that address the highest priority use cases may not need scale or processing power, but future analytics requirements will. To what extent can these future requirements be addressed purely by scaling up the capability of the platform? If you have a cloud-based platform, then you'll have the ability to scale. If you have more traditional on-premise application, your ability to scale to incorporate future needs may well be limited and so requires more upfront consideration of those requirements. If your future requirements go beyond volume and processing that could be addressed by scaling up, what additional design considerations are needed now to ensure a more seamless platform evolution? Do you need placeholders in your hierarchies that will allow additional data granularity to simply slot in when it's needed and be available without the need to rebuild all of your key dashboards and KPIs? Will you need to quickly adapt to changing market circumstances and bring in additional external data sets to enrich your forecasting? Key to initial design considerations is understanding technically and architecturally what exists and where within your organization, and so understand from which point you can confidently build your platform to address your prioritized use cases, knowing that extending it to accommodate additional use cases is relatively low incremental effort. You need to identify that point in order to optimize your approach. If we next look at technical considerations, what is needed to enable analytics to take place now, and what is needed to enhance this capability as the platform evolves? The first consideration is the capability within the organization and how they can get started. If your data scientists and or analysts already have some familiarity with certain tools, then to what extent can they be included in your platform? For example, there are some instances where you can achieve the same results by using a no-code approach or a coding approach, such as the possibility of using Databricks and MLflow, Databricks and Azure ML, or just Azure ML. If you're already building and deploying Databricks notebooks and using Azure Data Factory for your ETL, do you want to incorporate a new tool such as Azure ML or continue to use the existing setup? The experience and capability of your people may well determine your initial approach to tool use, and you will want to be able to evolve those tools to a more sophisticated platform as your resource capability matures. To be specific, many data scientists will be using Pandas instead of PySpark, for example. Databricks has more out-of-the-box functionality for Python packages than Azure ML does, so from an experimentation standpoint, it could be easier to get data scientists up and running using Databricks in the first instance. If the intention is not to continue on this basis, you will need to determine a roadmap for how to evolve towards your longer-term platform and ensure this is compatible with your initial implementations. Another core principle for consideration is cross-platform compatibility. As more companies consider going multi-cloud to reduce their dependency on any one provider, considering and designing with these principles in mind to ensure your code is as reusable as possible across platforms should be fundamental to the development of any enterprise data platform with analytics in mind. Next is standardization and best practice. Governance should be top of mind for any organization looking to build out an enterprise data platform for analytics. Once you start messing around in Azure ML and MLflow, it's pretty easy to see that model registries can easily become a mess. With an eye on industrializing your data scientist models with an MLOps approach at some point in the future, you also want to ensure that the use cases in your pipeline are adhering to any standards and best practices guidelines, as this will ultimately streamline this industrialization process and result in the successful delivery and support of ML models that deliver business value. Finally, we need to consider performance, which runs alongside all of the other considerations. Performance does not just relate to the speed of your application, but it can also relate to expectations around implementation of use cases. How long will a data scientist expect their experimentation models to become industrialized for wider use? How quickly can your organization analyze the new data that you have available to you? This latter point is relevant to your technical choices around which tools to use, and also your wider governance around use of best practice. In terms of speed, some tools will use in-memory storage, others will use container storage. Each will offer different results in terms of performance, but also consumption costs. So having some sense of cutoffs and limits for data volumes you're likely to be reading in and writing out now and in the future is likely to be a factor to consider when thinking about enterprise data platform design. Which brings us to and partially covers the final consideration, which is consumption. As has already been mentioned related to the other considerations, every design decision that is made either now or in the future will have an impact, positive or negative, on consumption. Tools that you use will differ in terms of how they consume data and how long they take to process data, and when and how you access data and what layers in your platform use it will have a considerable impact on consumption costs. For example, what is the implication of ingesting additional data now, whether this is additional data sets or further granularity, versus only ensuring that the capability is there now? You may even want to avoid enabling the capability initially, as this could impact timescales of initial deliverables. You can go as granular as you might want to at any point, but is there a potential cost and performance impact? Is this impact a consideration or indeed a problem before it needs to be? But simply, if you've architected to enable you to bring in the data that you need, but only need it at its lowest level to support advanced analytics during subsequent phases, why bring it in now if this means an increase in consumption costs before you are ready to consume that data? As a wider general point to finish with, data warehouses tend to be optimized for BI applications, but are suboptimal for data science, as they tend to be inflexible and technology and platform specific. Data lakes, on the other hand, are great for machine learning and data scientists as they're flexible and inexpensive, but lack enterprise governance. Your initial implementation choices can have a long-term impact on your ability to support your use cases.
Thank you, Paul. So now let's take a bit of time to look at different scenarios where we have helped customers to fulfill short-term needs to deliver business value whilst aiming for an enterprise data platform for analytics. Our first customer was starting afresh and wanted to ensure a business-led approach to building an enterprise data warehouse. Their objective was to develop an enterprise data platform to meet analytics and reporting requirements across the business. The platform needed the capability to provide standardized data as input to reporting and processes, as well as intelligent analytics to understand process quality and performance. The ask was pretty much, where do we start? The situation in this example was that this customer, after a series of acquisitions, had 3 separate platforms in place, developed over a number of years and each serving different parts of the business. The aim was to start again and design a platform that leveraged synergies in terms of the platform, operating model and support, but at the same time retaining a level of independence to give each of the business areas flexibility to meet their requirements. The solution was to balance 3 key objectives in order to plan the evolution of the platform. At all times, we kept user requirements and business value front of mind to ensure we were not expending cost and energy on anything that did not add value. For each identified use case, we mapped it to the organization's value objectives in order to quantify the likely value derived from delivering a product against the use case. We then used these value contributions to prioritize scheduling of both data and product, taking into account any cross-product synergies. The plan and execution of data and product delivery was based on this value contribution, and we included a user empowerment program to ensure that maximum value was derived from the platform from day one. Our second customer is a global consumer goods company, and their objective was to establish a single global data platform for external data to enable reporting of sales and distribution figures, primarily focused on the population of a single product dimension containing all required information for their and their competitors' product. The additional ask was that we use that as the starting point for then building a comprehensive external data mart, bringing in the local market data from their external sources and structuring it in a way that would enable reporting and analysis at a global and local level. The situation in this example was that all current reporting above a local level was a very manual process prone to errors. The customer realised the potential benefits of having a single data platform of external data that could be combined with internal financial data and so on, but previous attempts had proved unsuccessful, and so no one data set existed to facilitate reporting, let alone advanced analytics. The solution was to develop an approach to delivering value fast. The solution was delivered using an agile development methodology with Sprint Zero focusing on establishing the customer needs. We worked very closely with the business contacts to understand the nuances of the data, the views that were required for reporting and analysis, and most importantly, the business questions that needed to be answered. This project started just as the world went into lockdown due to the pandemic, which heightened the need for speed of delivery in order for the customer to understand changing consumer habits. This robust platform is now not only fulfilling all previous reporting needs, but also acting as a basis for data scientists to perform analyses such as price elasticity and steal analysis, and provides the basis for many other analysis opportunities to be realised. Now hand back to Paul to talk us through some other customer examples.
The objective of this next scenario was to re-platform an existing revenue growth management application from on-premise infrastructure to the cloud in order to benefit from cloud-based infrastructure and cost management, remove the cost of on-premise licensing, and produce a more modern and intuitive browser-based user interface. The additional ask was, how can we re-platform to meet the objective but build with analytics in mind? The situation in this example was that existing RGM analysis was based on a certain level of data granularity. Advanced analytics would require SKU level data, not currently available for end user reporting and analysis in the on-premise application, as it wasn't available in the product data store and reporting data layer, but was available at source. Pressing timescales due to the need to end expensive on-premise end-user licenses for the reporting tool that was being used meant there was insufficient time to incorporate all requirements in a first release. The solution was to plan ahead in terms of the capability that was going to be required. As mentioned, timescales did not permit the full integration of SKU level data into the reporting data layer during the first phase due to the additional overhead related to performance testing of including the increased volume of data in the full top-to-bottom solution and the potential implication on existing KPI calculations. As the additional data granularity was available in the data lake, it was brought into the redesigned reporting data layer together with all of the data required for phase one via the same ingestion processes. This minimized the additional overhead of bringing this data into the product during a subsequent phase, effectively creating a holding position for further use of this additional data. The application, successfully re-architected for the cloud, continues to be used for RGM analysis and is currently in phase 2 to bring in analytics based on the additional data granularity, with only business logic layer and end user interface changes required. The objective in this final scenario was to design and deliver an MLOps architecture that will enable full automation and industrialization of an existing tactical data science solution, which forecasts SKU demand across all customers at depot level for the next 6 months. The additional ask was, how can we re-platform this existing tactical solution to align with existing landscape architecture, ensure exceptional performance across data engineering and data science components, and enable a full MLOps lifecycle which will act as a scalable framework for the onboarding of future use cases. The situation was that the existing model was very much standalone, built by data scientists using their technology preferences, i.e. what they were familiar and comfortable with, rather than company standards, and was based on the manual load of multiple source data files from an AWS environment into the ML model, which forecast demand incorporating clustering techniques. It offered no scope for scaling up or across to other solutions without redevelopment. The solution here was to design and build an MLOps architecture that enables full automation and industrialization of the existing tactical solution. Re-architecting the existing solution with future analytics requirements in mind means that the MLOps architecture that has been produced now acts as a template for future data science applications. It automates, scales, and optimizes the data preparation into data engineering pipelines in line with company standards. It utilizes DevOps best practices for continuous integration and delivery. End-to-end automation plays a critical role in assuring data quality and reducing ongoing operational support efforts. So now to summarize. At the start, we need a clear vision of what success looks like. What are the critical steps in the end-to-end journey of ensuring data availability to solve business problems? And what checkpoints need to be ticked to ensure we end up with a successful outcome? Thorogood has been delivering analytics to customers for over 30 years, and throughout, our approach has been business-focused and inherently agile, with multi-skilled teams able to iterate fast with high communication levels. We focus on understanding business priorities and providing value fast through business-led continuous delivery. We take a think big, start small approach. Our approach is based on the fundamental principle that BI analytics is different, and it's different enough to warrant a specialist approach. We believe it's important that business goals and technical possibilities are understood hand in hand, so that project goals can be set to match technological capabilities. Keeping business goals to the forefront throughout a project is the key to ensuring success in BI analytics. Technology is a means to delivering value, not an end in itself. BI analytics projects require focus on understanding the information that users need and understanding how they want to use that information. The design of data structures is vital, as they should be meaningful to business users, designed for flexibility in query performance, able to support ad hoc analysis and reporting, and capable of evolving to support changing business needs. For each identified use case, map it to organizations' value objectives in order to quantify the likely value derived from delivering the product against the use case. Use these value contributions to prioritize the platform scheduling of both data and products, taking account of any cross-product synergies. As the platform matures, also incorporate any fit to existing platform data into this prioritization, i.e., does the data already exist in the platform or require additional data to be ingested? Plan and execute platform data and product delivery based on value contribution. Include a user empowerment program to ensure maximum value is delivered from the platform from day one. An approach should leverage the capabilities of DevOps tools to optimize efficiencies in the end-to-end process, combining operations and development into a single multi-skilled leverage team with strong understanding of the technical possibilities and a continued focus on iteratively delivering business value. And so with that, all that's left for me to do is to thank you for your time today. I hope you found this session useful. If you'd like to discuss any aspect of it with me or Evelyn, please feel free to contact us at these email addresses shown here. Thank you very much.